Hi, I'm Sahana Sriraj, a design engineer in the Linear Power Group here with Texas Instruments. Today I will be talking about a high current and high power density solution for an efficient DC to DC regulator. Also, as an example, I will use the LM27403 module just to go through it. So why do we need a high density regulator? Well, a lot of designers have a challenge of powering up numerous voltage rails with their system motherboard. Given the limitation in PCB area for power management, we want the regulator to be small in size, low cost, but high in efficiency. So how do we solve this? We use a small size point of load module with high current capability. Let's go over some of the key requirements for a high density solution. First up is high switching frequency. By this I mean anything above 500 kilohertz. This will reduce the size of the inductor. It will also reduce the size of the capacitive filter components. This will give a good transient response due to the higher loop crossover frequency. Next, we want efficient power MOSFETs. The high side and the low side FETs should be integrated to save board space. They should be low RDS on and low capacitance. The Pwm controller should be efficient and flexible with integrated gate drivers with adaptive dead time switching, integrated bias supply LDO as well. And lastly, we want the PCB layout to be optimized to minimize parasitics. For example, the power and gate loop area should be small and tight. For best heat removal, we want the PCB to be directly mounted on the motherboard. Moving on, I have the schematic of the module here. So we start from the extreme left. This is the Pwm controller, the LM27403. This drives the high side and low side FETs. Also, this is the input capacitor and the output filter capacitor. And lastly, we have the filter inductor, and very close to it is the remote temperature sensor. This is basically a diode connected BJT, which is small in size. This is a zoomed in image of the module we show here. Starting off with the power block next FET, this houses the vertically integrated high side and low side FETs. Next, we have the 300 nanohenry ferrite inductor for lower core losses. The DCR is a low of 0.29 milliohms. Here we have the Pwm controller, the LM27403 with integrated gate drivers and inductor DCR sensing. This is the input capacitor and the output capacitors. The input capacitor and the controller are placed very close to the high side and low side FETs to reduce the parasitic inductance. This ensures efficient high frequency switching. The board itself measures 20 by 15 millimeter in area. It is a 4-layer board with 2-ounce copper to have reduced resistance. Also, it has edge plating for power terminals. This is an efficiency plot with data from the actual module here. For example, for a V out of 1.8 volts at 30 amps, we have an efficiency of 91%. So we just showed you how to design a high current density DC-DC regulator without compromising on the efficiency. For more information on this, please visit us at ti.com/LM27403. Thank you for watching and have a great day.